Hello again, everybody. Last week we finished up learning about how the while loop works, and I showed you some basic examples as to how we can use loops. One of the common things that we can do with a loop, whether it's a while loop or a do while loop or even a for loop, which are things we're going to see in a little bit, is that you can use a loop for input validation. All right, so imagine that you have an example where you need to get a value from a user. All right, and what you need to do is make sure that a value is appropriate or valid. Okay, so the idea is what we can do is we can use loops to go ahead and continually prompt the user to enter valid values into the system before we just blindly accept their input. This is stuff you've probably seen before, like a web page or something like that. Or you fill out some form, right? You need to input values in a particular format, and if you don't, you just continually to get prompt with a response that you are entering invalid values. So let's take a look at a little example. So let's imagine that we have a system which is going to accept, I don't know, like test scores or something like that. And the idea is that we want to make sure that the scores that somebody is entering is valid, meaning that, let's imagine again, these are test scores, right? So scores would have to be somewhere in a range of 0 to 100. So we wouldn't accept any values that were less than 0, nor would we want to accept any values that were greater than 100. And if somebody keeps trying to enter those types of values, we'll prompt them with an error and let them continue to try again. So a good way to do this is by using a loop, and actually a while loop is a good type of loop to use. So let's take a look at a little example. So let's imagine here I'm going to have a local variable. I'm just going to call it score. And this is where I'm going to store the value that somebody enters. And here I'm just going to say, I don't know, cout, please enter a test score between 0 and 100. All right, something like that. So what we'll do here is we'll just capture the user's input. So we're going to capture this into the variable score. And imagine that what we're going to do is we're going to maybe what we want to do is accumulate a bunch of scores and then calculate the average or something like that. But what we're going to do is we're just going to display what the user input. So here we're just going to display, okay, you entered, and do something like this. All right, so I didn't do the validation. I'm going to do that now. So this is the idea. So somebody enters a score on line 8. All right, and then what we're going to do is we're going to essentially what they call echo, right? We're going to echo out the score that they entered on line 11. What I have here, this doesn't prevent somebody from entering anything outside of the range of 0 to 100. But what I'm going to do now is throw a little while loop in here, and I'm going to say while score is less than 0, or, right, the double pipes, or the score is greater than 100, I'm going to reprompt the user, and I'm just going to say some kind of error message, cout error score entered is out of range or something like that. Try again. And then here what we're going to do is do this, and then we'll say cin score. That's your work. So now it's going to happen. Let's just walk through this real quick. So imagine somebody enters the value 90. Okay, on line 8, somebody enters the value 90. Comes down here. This while loop will not execute because 90 is not less than 0 or 90 is not greater than 100. So my while loop won't execute, and then we'll just display the value that says you entered, and it should display 90. Let's imagine next time around somebody enters a value of -1. So imagine on line 8 somebody enters a value of -1. We come down here on line number 10. We check, okay, is score less than 0? Well, yes, -1 is less than 0, so that's true. Since that's true, and this is a or condition, all right, we don't even do the compiler, actually the program won't even do the test over here. Since at least one item is true, this whole expression will evaluate to true. So that will indicate that is in fact an error, and my while loop will execute. And the line number 11 will display and say, score is out of range, try again, and we're going to capture the score. So imagine on line number 12, somebody then enters a value of, 110, right? So execution is going to come back up to here. My while loop is going to see, okay, is 110 less than 0? Well, no, it's not less than 0, so that's false. But then we'll go over to here on the other side of the OR pipes, and I'll say, is 110 greater than 0? Right? Since that's true, okay, our while loop will then execute again, and I'll say, error, score, enter is out of range, blah, blah, blah. And then imagine the next time that they go around and they enter a value of, let's say they enter 100 or something like that. Execution will jump back up to here. Is 100 less than 0? No. Is 100 greater than 100? No, right? Since both of those things are false, right? 100 is not greater than 100, it's equal to 100. Since both of those things are false, my while loop won't execute again, and execution will jump down to line number 14, and it'll just say you entered 100. So let's go ahead and see this in action. Let this thing build for a second. Let me run it. Let's do the first scenario where it said, please enter a score. I probably should have put a semicolon in. I'll do that in a second. So let me enter a score of 50. Okay, you entered 50. Fine, that works, right? So that's within the range. Let's do this. Let's put a little delimiter in here just so it looks a little bit prettier when the screen is displayed. Control F5. Please enter score. So let me do what I had mentioned before. So I'll do like -1 over here. Right? So -1 is going to be outside of the range. So now I'm going to get prompted. The score you entered is out of range. Try again. Let me try something like 110. That's out of range. Let me try, -50. You get the idea. We can keep doing this over and over again. -20. And it'll continually just keep prompting the user until something is entered within a valid range. So here I'll finally enter a value 100, and it'll just say you entered 100. So that's how that works. So anyway, loops are super useful for doing input validation. The input validation in this case here is more along the lines of for an interactive type of system. If you were trying to do input validation and you were getting your data from like a file or a database or something like that, which we're going to learn in this chapter how to read and write from files. What happens is, since it's not interactive in that sense, you would probably want to write whatever errors that you come across or any anomalies, perhaps to the screen, or more than likely to some kind of like log file, so a user can then go back and see, okay, were there any anomalies when I was trying to input data into my system. So anyway, that's it. So play around with this a little bit. You'll see in the lab, I think we do something like this where you need to do input validation on a set of values. And let me just reemphasize here too, when I want to check for values that are outside of a range, okay, meaning outside of the range of 0 to 100, easiest way to do that is by using the OR operator. If you want to check for values that are within a range, say between 0 and 100, then you would use the double AND operator, okay, the logical AND operator. Don't necessarily need to do it that way. You could play around with the logic a little bit and kind of get the same thing, but typically you want to check for something outside of a range, use the OR operator. Want to check for something inside the range, use the AND operator. Another thing also, while we're using loops, it's common to keep track of a running counter of the number of times that the loop has executed. So again, when your program is written, there needs to be something in place which is going to cause your loop to eventually not execute. Otherwise, you're going to have what's called an infinite loop. And what you can do is every time that a loop does execute, you can keep track of the count. So let's imagine you have a system where you're prompting a user to enter a password or something like that. And if they enter their password incorrectly some number of times, let's say 3, that seems to be a common scenario, right? You enter your password incorrectly at 3 times, what you do is you get locked out of this system or something like that. So what we can do is we can use input validation along with like a counter variable to keep track of how many times something was perhaps entered into a system incorrectly, and if we exceed some threshold, we could lock the user out of the system or something like that. So let's imagine that we're prompting the user for a password, and let's imagine that their passwords are stored in a data repository somewhere. Usually there's some third-party vendor that provides these types of systems, or maybe they're just in a database or what have you. But let's just imagine that the user that is entering their password, it should be equal to the word secret or something like that. All right. So let's do something where we create a local variable here for the password that we're going to have somebody enter. String password. So that's where we're going to store the user's password. Let's keep track of how many attempts that they're allowed. So I'll make it constant. We'll call this max attempts. And we'll say it's equal to 3. And then let's keep a running count as to how many times that they entered the password into their system. All right. So here what we'll do is we'll create another little while loop. We're going to do a little input validation here, and we're going to say, first we got to get the password. Sorry. So I'm going to say cout, please enter your password. Please enter your password. So we're going to capture their password into password. Imagine the passwords don't have any white space in there. All right. Why is it complaining here? Oh, I forgot to include the library for string. Sorry, pound string. That works. All right. Please enter your password. Enter the password. Now we're going to say while somebody's password is invalid, what we're going to do is we're going to prompt them again to enter it, as long as they haven't reached the maximum number of attempts. So we're going to be responsible not only checking how many times that we're going to keep track of how many times that they've entered their password and check that against the max attempts constant, okay, with that variable here. So what we're going to do is we're going to say while password, while it's not valid, meaning that it's not equal to it. Again, let's imagine that this actual password is being retrieved from some third-party system, but let's imagine for our purposes here that the password has to be called secret. All right, so while the password is not equal to secret and count is less than max attempts, all right, we're going to say cout password is invalid. Please try again. Let's capture the password again. I'm going to capture the password, and we're going to keep track of the number of counts, all right, or number of attempts, which is going to be incrementing the variable count. So the idea is on lines 13 through 16, I'm sorry, this while, let me just highlight this. So the way the while loop is going to work is that if their password is invalid, meaning that it's not equal, they type something other than secret, okay, and as long as the number of attempts is less than max attempts, which is 3, we're going to continue to prompt the user. At some point in time, one of two things is going to happen. Either they're going to enter a valid password, or they're going to reach the max attempts threshold. So what we're going to want to do here, let's just put a little if statement here. We're going to say if count. So if they exceeded the threshold, so if count is greater than max attempts, max attempts count is greater than or equal to, I'm sorry. So if count greater than or equal to max attempts, to be honest with you, it'll never be greater than or actually, because once we hit the value of 3, the while loop will end. So we could really just say if count is equal to max attempts, that would work. But here we're going to say cout, we're going to say, I don't know, you are locked, or you can say account is attempts all right. Else we're going to say here we'll just say cout welcome, and we're just going to echo the password back out. Oops. Password. Okay, this should work. So the idea is that if they reach the threshold where they exceeded the maximum number of attempts, right, we're just going to display their count is locked and the number of attempts. Otherwise, we'll just say welcome into the system, whatever, blah blah blah, and then we're just going to display what their password is. So let's try this the first time around where somebody enters a valid password, and let's see what happens if they enter an invalid password. So remember, the password needs to be secret. Right? So if that's matches, we're good. So here it says welcome. The password is equal to secret. You can even play around this a little bit so you can't see the password as somebody's entering it. Now let's run this again where we exceed the number of attempts. So let's first type, I don't know, test. All right. So that's not a valid password. Password is invalid. Please try again. I'll type. Here's another thing, right? People use the word password. All right, password is valid. Please try again. I don't know. Please try again. Password is valid. Please try again. I give up, or whatever. Account is locked. Attempts is equal to 3. Actually, in this case here, the number of retry attempts is equal to 3, so the account will be locked out. So this is just another example as to how we can use loops to kind of extend input validation and using a counter variable. Very, very useful to use counter variables and loops, and we're going to see that a little bit when we're working with the do while and the for loop. All right, the next loop that we're going to take a look at is what's called the do while loop. And the do while loop is a little bit different than the while loop in a sense that the do while loop is what's called a post-test loop. So the while loop is a pre-test loop. The do while loop is a post-test loop, meaning that the test, the conditional test for the loop is done at the end of the loop. Basically, what it means is that the loop is guaranteed to execute at least one time, even if there's an invalid state. And the syntax looks like this. All right, this is out of your books, like around page 243. Actually, I think it's in sync with your book. The syntax looks like this. We start with the keyword do, and then you have a statement while expression. So the while expression is no different than like we had seen before. So as long as something is true, keep doing something. One thing that's worth pointing out is the do while loop is terminated with a semicolon. It's kind of an odd place for a semicolon syntactically, but C++ and actually C and C++ and Java do the same exact thing, just for your reference. Typically within a do while loop you would have multiple statements or a block of code. So the format would probably look more similar to this, where you'd have do and then you have a pair of open and closing parentheses, while expression, and then you have a semicolon. So again, that's the syntax. Again, the keyword, the key thing to understand is that the do while loop is a post-test loop, and also just remember that you always have to terminate the thing with a semicolon. What I'm going to do now is I'm going to show you a little example, and I think the one out of the book here is pretty good. I want to do something like this. This is the logical diagram for a do while loop. But what we're going to do is we're going to do this. I'm going to throw this little program together in a second. We're going to I'm going to write a little program which is going to prompt the user to enter a couple scores, and we're going to average those scores, and we're going to keep doing that over and over again until somebody enters Q for quit or something like that. Here we'll say while again is equal to Y. So the idea is that we're going to keep prompting the user to enter values until they decide that they want to terminate out of the program. So at a minimum, this do while loop will execute at least one time. All right. So let's throw this little example together, and I think it'll make some sense to you. So let's create some local variables. Int score 1, score 2, score 3. So let's do double. Let's average these things up. Let's average these things. Double, average, and then let's see here. Let's do char again. Well, let's do this. Do call. No, I can't use the word continue. That's the keyword again. So score 1, score 2, and score 3. That's what's going to prompt. That's going to prompt the user. I'm sorry. Those are going to be the variables that we're going to use to store the values. Average is just going to store the average of those 3 variables, and again is going to be the thing that we're going to test, whether or not to enter uppercase or lowercase y. That's the idea. You might notice here that I declared score 1, score 2, and score 3 as integers. Once I add those 3 variables up and average them, they could be right. The average of those things could be a double, so that's why I declared the variable average as double. I could have also declared score 1, score 2, and score 3 as doubles also. So the format of the do while loop, I'm going to say do. Okay, there's my block statement. While. Okay, while again is equal to uppercase Y, or again is equal to lowercase y. And don't forget here you must have the semicolon. Why am I getting an error message here? Oh. Oops, sorry. Syntax error here again is equal to y. Do y. There we go. All right, so let's prompt the user. All right, so cout, please enter 3 scores. Separated by a space, something like that. All right. And now what we're going to do is we're going to capture those 3 values into score 1, score 2, and score 3. We can do that all in one line. I think I showed you this, guys, in a previous example that you can capture multiple values as long as it's separated by the stream extraction operator. All right, please enter the score separated by space. We capture the scores. Let's average those things up. So here we're just going to say average is going to be equal to score 1 plus score 2 plus score 3, right, divided by, remember here, score 1, score 2, and score 3 are all integers. If I add those things up, it's going to be integer. If I divide it by another integer, it's going to do integer division, which isn't what I want to do. So I want to put something on the right side of my division operator to force it to do double division. For those of you that still might be unfamiliar with this, and I've noticed in some of the labs, you guys have made this mistake, check out what the difference is if you divide by 3 as opposed to 3.0 and look at the different results. Okay. If not, go back in the book and take a peek at how integer division differs from double division. All right, let's do this. So let's just display what the average is. So we'll just say cout, average is equal to average. Okay. And then what we're going to say, do you want to continue? Cout. Do you want to continue? Y or Y? We'll let them input either one. Do you want to continue Y or Y? Cin. Let's capture this. All right, it looks like it should work. So what happens is, regardless of what the value is of this variable again, which is declared on line 8, this loop is guaranteed to execute at least once, right? Because what happens is on line 10, that's where the do while loop begins, and lines 11 through 17, okay, which is the block of the code, will execute at least once, okay? Even if somebody wants to, enter no, they have to at least run this one time. So let's imagine first time around somebody enters 3 scores, we calculate the average on line 13, we display the average, we prompt the user again on line 16 if they want to continue. So let's imagine the first time around they hit, N, right, or something Q, whatever, anything other than Y or Y. What happens is this will fail, okay? Since this fails, this loop won't execute again. Second time around, let's say they run this program, they enter some scores, we display the average, prompt them, do you want to continue Y or Y? Let's imagine that they enter the upper or lowercase y. Here, if they enter lowercase or uppercase y, this expression will evaluate to true, and we'll come back up here again and do this over and over and over again until they enter something other than y. So you notice that this allows us to get rid of like our original priming read, and also you kind of see how a post-test loop works. So let's just do this. Let me run this once. The first time around, we're just going to enter a couple scores, and then we'll hit N or something like that. So let's type what's something that's not going to be evenly divisible. Let's do like 51, 25, and 71. Okay, that won't be evenly divisible by 3. The average is equal to 49. 6, 8, 49. Let me see what the average would be. Okay, that works. Do you want to continue? So let's imagine I type something other than Y. So I just type Q. Probably a better idea to have, say, a better prompt than this. Y to continue, Q to quit, X to exit, something like that. But kind of get the idea. So first time around on line 18, Q is going to be stored in the variable again, since Q is not equal to Y, or it's not equal to, Q is not equal to uppercase Y, or it's not equal to lowercase y. My loop will terminate, and that would be the end of my program. Let me run this again, and let's run this multiple times now. So let me enter some values again here. I forget what I entered. 51, 41, I don't know, 90 or something. All right, it tells me what the average is 60.6667. Do you want to continue? And here what I'll do is I'm going to type in lowercase y. Now my while expression then here on line 18 is going to evaluate to true. So I'm going to get the prompt once again. So I'll make up some numbers here, 50, 60, 70. There's the average. Do you want to continue? Here I'll use uppercase Y just to see that it works for both conditions. Enter some more values, 10, 11, 90, 1, whatever. Gives you back the average. Do you want to continue? Let me just do it one more time. All right, there's Y, and we'll do 10, 20, 90. Do you want to continue? Hit X, and now my program terminates. So that's how we can use a while loop to at least to display something or cause execution to occur at least once. All right, the last loop that we're going to cover in this course is actually it's really the last loop that's available within C++. Except there is one little loop that's available in the new version of C++, and it's what's called the enhanced for loop. But that's a side note. Anyway, so the last loop is what's called the for loop, and the for loop differs slightly from the while and a do while loop. It is a pretest loop. However, it's not what's called a conditional loop. It's what's called a counter controlled or a count controlled loop. And the idea is that with a for loop, it's a great loop to use when you know exactly how many iterations something is going to execute, which more often than not is the case. So it's at the end of the day, the trick is kind of to understand, which loop is going to serve the purposes that I'm going to be doing for a particular task. Quite often, you know ahead of time how many times a loop is going to have to execute, and if that's the case, then you can use a for loop. So you'll see that the for loop is probably the most common loop that you'll come across. The while loop will be a close second, and the last one would be the do while loop, which I have to say is used the least frequently. And so with the syntax works something like this. Uh, Here's the syntax. So I'm going to skip this one up here because just as with the other loops, all right, this is for if you have one statement, but typically with a for loop, you're going to have a block statement. So the for loop was broken up into 3 steps. All right. So for is the keyword. All right. And then you have a pair of open parentheses. You have an open parenthesis. Then you have something which is called initialization. Okay. Initialization is going to be the thing where the step where you're going to initialize a variable to a particular value. Second part is the test. Okay. If the test is valid or the test is true, okay, then the loop will execute. Once the loop is done executing, we come back up to our top of our loop and we update our variable, which is typically done in the initialization step, and we do the test all over again. So the idea is that with the for loop, we'll keep doing something as long as this test is evaluates to true. Keep executing the loop. Once this expression and test evaluates the false, the loop will terminate and the program will continue after that. It's important to note that with the for loop, each one of these, we call them tokens, is separated by a semicolon. So just be aware that it's not a comma; it's a semicolon. So let's take a look at a little example. I'm trying to see if there's anything else that we need to do in here. One thing is important to note here. Okay, the update expression. The update expression, which is this part over here, will execute at the end of the iteration of the loop, and it's important to understand that whatever that update expression is going to be, at some point it must cause your test condition to evaluate the false. If not, you're going to have the same problem that we had in the past, where you would have what is referred to as a infinite loop. And here, this is a good ending sentence here. It says typically, right, the update expression, typically this is a statement that increments the loop's counter variable, which is a thing that's created within the initialization step. So let's throw together a little program here, and hopefully this will kind of clear things up for you. So again, the way that the syntax works is that the keyword is for followed by a pair of parentheses. This line of the loop is what's referred to as the loop header. So the first step is to create the initialization step. So here I'm going to create a variable. I'll say int num is equal to 1. So we're going to declare a variable of type integer. I'm going to call it num, and I'm going to initialize with the value 1. The next step is the test expression. The test expression is going to be something that has to evaluate to either true or false. So here I'm going to say while num is less than or equal to, let's say, 10. So I want my loop to execute 10 times. And the last part is going to be the update part. And the update part is going to be where at the end of each iteration of the loop, this little statement here will execute each time. So I'm going to increment the value of num. So the idea is that within this for loop, we're just going to create a little table which is going to display the numbers 1 through 10 squared. So we'll display 1, 4, 9, 16, that kind of thing. All right, it'll display the first 10 numbers squared. All right, so let's just display what the value of num is. I'm going to say cout. I'm going to display num. And then we're going to display the squared value. I'm going to put the tab character in here just so that we can kind of line things up into nice clean columns. Actually, it should be okay. These numbers aren't going to get too big, so it'll fit. And then what we're going to do is going to display num times num. All right. So I just wanted to make this a one-liner just so that we can walk through this. So again, on line number 6, this guy here, this is what's called the loop header. All right. Once execution comes down to line 6, okay, we're going to declare and initialize a variable that's called num, and we're going to assign it to value 1. This step here occurs only one time within the body of the loop, or the execution of the loop. Once this expression is initialized, that's why it's called the initialization step, then this test is done. The test is to say, okay, is num less than or equal to 10? Well, in this case here, num is equal to 1, so 1 is less than or equal to 10. That's clearly true. Since that's true, come down here, execute the body of the for loop. In this case here, the body of my for loop is just a one line, which is going to display the number, the tab character, and then a number squared. All right, so it's going to do this. Then execution comes down here. This is the end of my for loop. Then the execution comes back up here to the update expression, and it's going to say num plus plus. So now num will become 2. Come over here, we evaluate our test. Is 2 less than or equal to 10? Yes, it is. So we come down here and we display line 7 again. So we'll display 2, tab, and then 4. We come down to here. Execution then jumps back up to here. Num plus plus, so 2 now becomes 3. We do our test. Is 3 less than or equal to 10? Yes, that's true. We execute line 7. This executes. We jump down to here. Execution then comes back up to here. Num is now equal to 4. We do our little test. We test is 4 less than or equal to 10. Jump down here. Execute line 7. It's going to display 4, the tab, and then 16. It's going to keep doing that until num plus plus becomes, okay, once this evaluates to be 11, we come over here and we do our test and we say, okay, is 11 less than or equal to 10? Now this finally is going to evaluate the false. Since this evaluates the false, the body of our for loop will no longer execute, and that's the end of our loop. So we are in a condition where we aren't going to have an infinite loop. So let's take a look to see how this works. It's pretty straightforward. I would suggest that I would read through this section in your book and just be sure that you're familiar with how for loops work, and there's some other little nuances that you might want to play around with where you can do the initialization and where you can do the update. I don't want to give you all of the examples here because it's going to make this video quite a bit longer. I want to just kind of keep it simple for now, but there are ways that you can sort of tweak the header of your for loop to somewhat make it non-standard, but it will work for you. So this is the most common way that you'll see a for loop, but there are some small modifications if you want to look into it a little bit further, you can. So anyway, let's execute this thing. Let's see what we get. All right, so we display each number and we display the number squared. So anyway, that works. One thing I want to point out to you too is that we, within the body of our for loop, oh, actually, I'm sorry, within the loop header itself, this update expression doesn't have to be num plus plus, meaning that we don't need to, this doesn't have to be a simple expression where we're just incrementing a value by one or decrementing a value by one or what have you. There's no reason why I can't do something, listen, say where, num plus equals, I'm sorry, plus equals 2. All right, meaning that what I'm going to do is I'm going to not increment num by 1, but I'm going to be incrementing num by the value 2. And if I do that, what's going to happen is we're going to be skipping some numbers in between, but nonetheless, my test expression still at some point is going to evaluate default. So anyway, the point I want to try to make here is that you don't need to always do num plus plus or num minus minus. It can be any kind of valid update expression, however complex you want it to be. So if I do this, so it should start at 1, then it will go to 3, and then 5, and then 7. So it's going to skip the even numbers, right? So it'll go 1, 3, 5, 7, 9. Okay, if we want to display the even numbers, okay, you would just start at 0, and then a new num plus is equal to 2, that kind of a thing. So anyway, the point I want to make here is that this expression doesn't need to be num plus plus or num minus minus. Typically, it's the case. Almost always, you'll see something like that, but there are other variations of that. Last thing I want to cover real quick. Another common thing to do within a loop is use our counter control loop to keep a running total, and this is something that you're going to be using within the lab. So let's imagine that this is some like little statistical program, and we need to keep track of the number, the sum of the squared numbers. All right. So what I want to do is as I'm executing my loop, I want to have another variable that we're going to use to keep to essentially keep a running total. So let me declare outside my for loop. I'll just call this int total, and I'm going to say that's equal to 0. Let me do this within my for loop. I'm going to say int num squared is equal to num squared is equal to num times num, right? And then what we'll do here is just display num squared, and just kind of shortening things up here a little bit. And what I can do is the variable on line number 6 is declared outside of the body of my for loop. Okay, however, that variable is still within scope of my for loop because it's declared outside of my for loop. So within my for loop, I can see the variable that's called total. So what I could do here is I could say total plus equals num squared. What that will do is that is going to keep a running total of the squared numbers within my program. And at the end, what I could do is, maybe I don't want to display this on each line, okay, but I could say cout, I could just say sum of squares equals something like that. So my program will, let's do this so it's on a new line. So here on line number 10, this is where I'm actually going to be keeping track of my running total. It's important to note here that on line number 6, I initialize total to 0, which will allow me to say total plus equals num squared because it starts off with 0, so it'll be 0 plus 1. Next time around, it's going to be 1 plus 4, so on and so forth until we reach 10 times 10, which is 100. At the very end, right, so my loop's going to execute 10 times. Once it hits 11, the loop will terminate, and then execution will come down to line number 13, and this is where we're going to display the sum of the squares. So let's see what the result is that we get here. Sum of squares. So here we're keeping track of essentially column number 2, right? The 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Right? The sum of those squared values will be equal to 385. So again, the point I want to make here is that it's a common thing to do, and I think this is actually the next section in your book, probably like 5-7, is keeping track of a running total. So that's it. That's all I'm going to cover for today. I would suggest that besides doing the labs that I assigned to you, I would take a look at some of the examples that are in the book and really familiarize yourself with how loops work. And the way that loops work in C++ is the concept is very similar to loops in any other programming language. So if you understand this concept and you need to implement this in another language at some point in time, you'll be able to get up to speed, really quickly. So that's it. So again, just a quick summary, right? So for loops and while loops are what are called pretest loops. A do while loop is a post-test loop. And in addition to that, a for loop is typically referred to as a counter control loop. That's it for this week. Have a good week, and I'll see you later. Bye bye.